All right. Good afternoon once again, Dutrow Dolphins. This is Mr. Wheeler, third grade teacher at Dutrow, bringing you some math now. Uh, the teachers and I have broken up the week three packet. Excuse me, not the week three, the third packet. This is week 5 of online learning. We have broken up the third packet into chunks. So each teacher is doing a little bit of the reading, a little bit of the math, and a little bit of the content. So for math today, Mr. Wheeler has column 3. So if you have your packet, or if you don't, you just look on the screen, you see that Mr. Wheeler is going to do these two problems here because columns go this way, rows are flat. So I have the problems that start with imagine you have a collection, and then Christian, Madison, and Abby. All right, so I think the first thing, I'm in reading. The first thing that I should probably do is start reading these questions so that I can understand what I'm talking about. All right, so it says, imagine you have a collection of less than 50 pennies. When the pennies are put in groups of 2, there is 1 penny left over. When they are put in groups of 5, there is also 1 penny left over. How many pennies could there be? Explain your thinking using pictures, words, and or numbers. All right, Christian, Madison, and Abby each have a different set of stickers. Christian has 10 more stickers than Madison. Abby has 10 less stickers than Madison. How many stickers could each person have? How do you know your numbers make sense? Explain your thinking using pictures, words, and or numbers. All right, so Mr. Wheeler, before we even begin, I'm going to start off by saying that these problems took me a bit of a while to figure out on my own. Because I do believe that they're kind of like tricky problems. So what really kind of helped me to make sense of them, friends, is Mr. really kind of used the like the Newport News Public Schools word problem solving template. So I kind of thought about what my question was, what do I know, thought about what my question was, what do I know, um, sorry, yes, what my question is, what do I know, how I'm going to solve it, and how to make sure that my answer makes sense. Woo, that took a while. So friends, with that first question about the pennies, that's how we're going to make sure that we master our first learning target. I think by taking these steps, we're going to ensure that we have an accurate answer, but also an answer that makes sense using mathematical language and pictures, which is our ultimate goal. So friends, I tried my best. I believe these answers to be accurate, friends. If you come up with something different, please let me know. Mr. Wheeler is not ashamed to be wrong. Help me out. So friends, firstly, what is my question? How many pennies could there be? I'm starting off with that question. But friends, there's like some things we have to consider. There are some caveats, if you will. We know from our problem that there must be less than 50 pennies. Um, so we can't have any more than 50 pennies. In groups of 2, there is 1 left over. And in groups of 5, there is 1 left over. So what I firstly did was I didn't really draw a picture, but I like made a picture using some pennies that I found online. And when I first did this, um, the first answer I kind of came up with was 6, which is incorrect from my understanding of this problem. So, friends, I kind of went through my 3 steps. I went here. There must be less than 50 pennies. Friends, 6 is much less than 50. So, in groups of 2, there is 1 left over. So, if Mr. Lee has these 6 pennies, and you see they're organized into rows of 2, I don't have any left over. The reason I thought this worked is because when I had a group of 5 pennies, 1, 2, 3, 4, 5, I had the 1 left over. But it didn't work for the group of 2. So 6 did not work as an answer. So, and I could be wrong about this, friends. So I'm going to start off by saying that I was doing some deep, deep mathematical thinking. And I realized that the smallest possible answer I think I can have is like, oh, see, now I don't want to say it. But friends, I know that my answer at least has to be greater than 10. And the reason I think it has to be greater than 10 is because when I consider the numbers 2 and 5, friends, 10 is a multiple of both 2 and 5. It's the least common multiple of both 2 and 5, which is something you'll learn in fourth grade next year. So I know that my answer had to be at least greater than 10 because I needed to have a number that could represent groups of 2, but also represent groups of 5. And the smallest number or the smallest multiple that can represent both groups of 2 and groups of 5 is 10. However, I know that I need to have 1 penny left over. So when I tried 10, if I have groups of 2, let me just move this one over here. If I tried 10, Mr. Wheeler, in groups of 2, I have 5 groups of 2. I don't have any left over. And if I tried groups of 5, I have 2 groups of 5, and I don't have any left over. So Mr. Wheeler then thought to use an additional penny. So if I do it this way, if I have groups of 2, 1, 2, 3, 4, 5. When I have 5 groups of 2, I now have 1 left over. If I do groups of 5, and I put that there to make a group of 5, I put that there and scoop that one over, I now have 1 group of 5 here, and I have another group of 5 here. And then I have 1 penny left over. So Mr. Wheeler thinks that his answer is going to be 11. And I actually kind of went ahead of myself, but it's fine. So what am I going to do to solve the problem? Friends, count out groups of pennies until the amount makes sense. I think that this makes sense. And the reason I know that it makes sense is because I'm going back and I'm checking to make sure that it met all 3 criteria or rules. Criteria is just a fancy way of saying rules. All right, so again, there must be less than 50 pennies. Friends, 11 is definitely less than 50 pennies. In groups of 2, so let me make my groups of 2 one more time. In groups of 2, when I have 11 pennies, there is 1 left over. In groups of 5, I now have my 2 groups of 5. I have 1 penny left over. So friends, it meets all of the criteria or all of the rules established by the problem. So I think 11 works. I'm super excited about this problem, friends. I hope that my answer is right. And I went to this cool thing called Coinbox Online to, kind of like double check and kind of just to see it a bit differently. So friends, you can use Coinbox. I'll put the link in the description box or the comment section below, and you guys can go to Coinbox and have a good time, do all kinds of stuff. You can use Coinbox for many kinds of things, friends. You guys will be going to fourth grade next year. Understanding money is crucial and very, very important to understanding decimals. So play around on Coinbox. However, I'm using Coinbox to solve this problem here. So here, Mr. Wheeler has his coins organized into 2 different ways. Here, I have groups of 1, 2, 3, 4, 5. I have my 2 groups of 5 and 1 left over for a total of 11 cents. And here I have 1, 2. Need to add more pennies. That is incorrect. Let me drag 1 over, and let me drag 1 more over. Thank you for your patience, people. All right, so now I have 1, 2, 3, 4, 5 groups here, and 1 left over, 11. So Mr. really does think 11 works as an answer. The reason I love this problem and the reason I find it so difficult is because I think that there are multiple correct answers, friends. So let me go here and show you this. Oh, friends, by the way, ignore where it says collect 33 cents and collect 72 cents. I'm not doing that part of the activity. I'm just using these coins to get my point across. So here, if you need a second, friends, go back and, pause the video, not go back, but rather pause the video and count the coins here. All right, so here, Mr. Wheeler thinks I have 21 coins, and here I think I have 21 coins. Here, the coins are kind of organized into groups of 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Again, I have my coins organized into groups of 2, and I have 1 left over. Over here, I have my coins organized into groups of 5, 5, 10, 15, 20, and then 21. I have my 1 left over. So I think 21 works in the same way that 11 works. So with that being said, I'm going back and I'm thinking about, does it meet my 3 rules or 3 criteria? Is it less than 50 pennies? Yes, friends, 21 pennies is less than 50 pennies. Can it be organized into groups of 2 with 1 left over? Yes. I have 10 groups of 2 with 1 left over to make 21. And here I have a third rule. Can it be organized into groups of 5? Yes, friends. Here I have 4 groups of 5 with 1 penny left over for a total of 21. So if you got this without Mr. Wheeler, great job. If you needed my assistance to get unstuck, friends, still great job. If you didn't get it, but you tried your hardest, friends, still great job. What I want to challenge you to do now is to find some other correct answers. If I have done this correctly, friends, and if I haven't, again, I'm sorry. But if I've done this correctly, friends, I believe that there are at least 2 more answers that you can find. So what I encourage you to do is to play around on Coinbox. Friends, this is, you know what? These are the moments where I really, really miss you guys, because you guys, talk with problems, talk me through problems, like help me understand stuff too. So friends, know that you guys are missed. Hopefully this makes sense in understanding that problem. So the 2 answers that I found were 11 cents and 21 cents. And I think they meet both of the criteria as established in the problem. All right. Whew. Friends, that was hard. Mr. Wheeler is flabbergasted. Not really, but it's a fun word to say. All right, so friends, next problem. We did this first one. We've accomplished half of our learning target. We kind of went through that Newport News word problem solving format to help us understand what's going on. You think about your question, you think about what do you know, you think about how you're going to solve the problem, and you think about how your answer is going to make sense. If you're at home, friends, I encourage you, when you're solving these kinds of word problems, and excuse me, I got ahead of myself. When you're solving these kinds of word problems, friends, to take a sheet of paper, if you have paper at home, and fold your paper into fourths or into 4 sections, and kind of label them. Question: what do you know? How am I going to solve it? How do I check, friends? And I think that's super, super helpful in organizing your work. Remember, friends, you only have to submit 2 samples of work. However, if you guys are smart, and I know that you guys are, and if you guys are hard workers, and that you guys are, my hope is that you will try at least more than 2 problems, friends. All right. So with that being said, second problem. Christian, Madison, and Abby each have a different set of stickers. Christian has 10 more stickers than Madison. Abby has 10 less stickers than Madison. How many stickers could each person have? How do you know your numbers make sense? Explain your thinking using pictures, words, and or numbers. So I kind of had like an opposite, feeling when I looked at the first problem. The first problem, I thought this one was super hard. It took me a long time to figure out. This second one, at first glance, I thought it was super easy. And I still kind of think it's easy, friends. But I'm just like, the problems like this are always tricky. So friends, hopefully what I have done in establishing like my, my question, what do I know, my problem, how do I solve all that good stuff, friends? Hopefully it will help to elucidate or make clear what Mr. Wheeler is trying to say. So let's go ahead and see. So going back to sharing my screen. That's my first problem. Let me scroll down and find my second problem. Okay. So what is my question? The question, and remember, friends, I took the question directly from the problem. It says, how many stickers could each person have? How do you know your numbers make sense? So friends, what do I know? Stop right here. So Christian has 10 more stickers than Madison. Abby has 10 less stickers than Madison. So with that, Mr. Luther kind of made like a little bit of a number sentence. So Christian, the number of stickers, so Christian represents a number in this case. So the number of stickers Christian has is greater than the number of stickers Madison has because Christian has 10 more. Mr. Wheeler then realized that the number of stickers Abby has, or rather, the number of stickers Madison has is greater than the number of stickers Abby has because Abby has 10 less. So Christian as a person or as a number is greater than Madison, and Madison is greater than Abby because Madison has 10 more than Abby and Christian has 10 more than Madison. So Mr. really got to thinking, and I think this makes sense. So using this logic here, I'm pointing to the screen, but you guys have it right there. Using this logic here, I kind of established some other things. So friends, Christian has at least 10 stickers. From reading this first part of the problem, if Christian has 10 more stickers than Madison, he at least has to have 10 stickers. All right. But then I kept doing some more thinking. So friends, I also kind of realized that Madison has to have at least 10 stickers as well because Abby has 10 less stickers than Madison. I can kind of flip that around. Madison has 10 more stickers than Abby. So Madison has to have at least 10 stickers. So friends, if Madison has to have at least 10 stickers, and we know, going back up here, that Christian has 10 more stickers than Madison. Does anyone think they know what Mr. is about to say next? You can pause it and think if you need to. All right. So friends, therefore, if Christian has at least 10 more stickers than Madison, then Christian must have at least 20. So that's kind of what I thought made sense when I was solving this problem. So I can cross out that first bit of information because it's no longer valid because I've like went through my whole problem. So we know, friends, that Madison has to have at least 10 stickers and Christian has to have at least 20 stickers. All right, so friends, how am I going to solve this problem? I'm going to think and count and then make sure that I follow the rules that I made. So the rules that I made: Christian has more than Madison, Madison has more than Abby, Madison has to have at least 10 stickers, Christian has to have at least 20 stickers. So I'm going to think and count. Give myself a little space. Come on, Smart Notebook. Give myself a little space to work. Perfect. So Madison has at least 10, Christian has at least 20. So I can start off small. So let me start off with a small number to represent whose stickers, friends, like think, whose stickers do I need to like think about representing first? Probably Abby's, because we have a lot of information about the amount of stickers Christian and Madison has. So friends, we just kind of just have to like check, like guess and check and see what makes sense. So Abby, let's say, you'll start small, 5. So friends, if Abby has 5 stickers, and we know that Madison has 10 more, Madison has to have how many stickers? We have to do what operation? We have to add. 10 plus 5 is very easily 15. All right. So then Christian must have how many stickers? If Christian has 10 more than Madison, what's 15 plus 10 more? We can add 10s very easily to get 25. All right. So friends, I'm going to go back and make sure that I follow up my rules here. Madison has at least 10 stickers. Madison has 15. 15 is greater than 10. That checks off. Christian has at least 20 stickers. 25 is greater than 20, so that makes sense. And let me go back up here. Christian has to have more than Madison, and Madison has to have more than Abby. 25 is more than 15. 15 is more than 5. So friends, it works. Let me try one more. Let me like raise the level of rigor significantly here. So friends, Mr. Wheeler is going to try 143. So Abby now has 143 stickers. Let's see if we can use that same mathematical process to make this make sense again. So Abby has 143 stickers. Madison has to have at least 10 stickers. She has to have 10 more than Abby. So friends, if I have 10 more than 143, Mr. Miller already knows that only one digit is going to change in this number. Which digit is going to change, friends, if Madison has 10 more than Abby? The 1, the 4, or the 3? Which digit? It's going to be that 4 in the tens place, friends, because I'm adding 10 more. So 143 plus 10 more is, if you need to solve this on paper, friends, please do so. Pause the video. 143 plus 10 is 153. All right. So, friends, Madison now has 153, and Christian needs to have 10 more than Madison. So, if I'm at 153 friends and I'm adding 10 more friends, you guys are great at picking up patterns. Friends, 10 more than 153 is 163. So again, I got to go back up, make sure all of my stuff makes sense. Does Christian have at least 20 stickers? Yeah, he has 163. That's a lot. Does Madison have at least 10 stickers? Yes, she has 153. That's a lot. Does Christian have more than Madison? Yes, we know that. Does Madison have more than Abby? Yes, we know that. So friends, I think that this works. This problem seemed a lot easier to Mr. Wheeler. Um, if you have found something that I missed, please let me know. Remember, I'm not ashamed to be wrong, but I want to make sure that I am teaching you guys the things that you need to be your most successful. All right, so friends, that's the math for today. I had the column 3 math problems, which were these 2 problems. If you need help with some of the other problems, friends, you know that you're going to go have to find another teacher's videos on the YouTube channel. All right, so thank y'all so much for watching. I really appreciate you guys working with me today. I miss you guys a lot, and I hope that you guys have a great rest of your day. Thank you very much for your time.